Hi everyone, welcome to lecture 5, and in this lecture we will be looking at offensive security. Okay, of course there are other pieces that we'll be looking at alongside the offensive security. We'll be looking at things such as footprinting, and we'll be looking at social engineering and password. Okay, so let's get started with it. So the backstory, together with everything encompassing and putting it together with what we looked at last week, we looked at the cyberkill chain last week, and we learned that the whole concept and idea of security research was all about auditing testing systems. So in a sense, we test out a security architecture that was built, and this is so that we can perform what is known as continuous integration and continuous development. So what this is all about is just to say that we build a system and we test it and we build on top of that one without the idea of rebuilding it from the beginning. And that's what continuous integration is all about and continuous development. Okay, it's all about continuously improving the system as we proceed. So it's all about testing the security architecture and improving on top of the security architecture based upon the weaknesses that were found during that auditing stage. And researching, if you recall, we said that researchers, they all start with scoping. And the scope, remember, the documentation that outlines all the computing systems, the domains and computers and everything else that is open for you to perform auditing. That is also something that we have to start with first, okay? And it basically explains what are the targets of evaluation open to you, okay? And then later on, we're going to be looking at CTFs, okay? And CTFs are just a way of you to get to practice your own penetration tests and ethical hacks, in essence, and you get to practice them and get better and better and better. So it's a much more safer environment for you to do so. Okay. So where does this all begin? Again, it starts with the cyberkill chain. And quite honestly, CTFs are very, very, very threatening, and they may be seen in some cases as a little bit challenging by some people. Okay. So follow the cyberkill chain, it will guide you. Okay. And if the cyberkill chain seems a little bit too much, there's a much more simplified, which was created by the Hacker Evolution, which simplified the kill chain into a few steps, such as scanning, cracking, accessing, and escalation, action and objectives, and maintaining access. So scanning, it's the equivalence of information gathering. So in this case, we're gathering as much information as we can, but this is more focused, in fact, on a specific host or a specific computer or a specific target rather than an entire entity or an entire business. So when you're performing scanning, you're performing simple things like your nmap and the harvester and so on and so forth. You're actively finding those vulnerabilities. And then this one may be a little bit optional, which is cracking. The concept of cracking now is to get any passwords that you may require for performing that accessing stage. Okay. Then once you have that, you can proceed to accessing. And this is entirely where you're now interacting and you're logging into the target host. Then followed by escalation. Remember, privilege escalation was the concept of getting root access or getting administrators access or getting the highest privilege access possible. And once you have obtained this, then you can take a look at your action on objectives. This is where you are now doing what you are supposed to do, whether it was to get a file or it was to copy a file or delete a file or whatever it is. That's where you will be doing it along the action on objectives. And then maintaining access is a little bit subjective depending on what you're doing. This is where you can create something like a backdoor of some sort, which is for you to just come back and log in the next time you need to access that machine again without having to go through the hassle that you did all again. Okay. And if you look at it, this is not really that different from the cyberkill chain that we looked at in the past week. It's not exactly as different, it's just more simplified for a specific target or a specific machine. And I cannot stress this much, your best friend for all of this is your advanced penetration testing distributions. That is your Kali Linux, your Parrot machine, your Cyborg, your HackTheBox, whatever it is that you're using. In my case, I'm using none of these. Mine is more custom built for this. But anyhow, everything starts with information gathering and footprinting. Of course, footprinting might sound like a gibberish word that we all have no idea what on earth footprinting is all about. But footprinting is just manually browsing the host and seeing what you can find along the way. Okay. And then there's information gathering, you recall. So here we're just looking at some of the tools of trade that we can use to perform these two: information gathering and footprinting. Excuse me. So this is always the first step. So we can use a certain tool like Nmap, which is the network mapper, to find details in particular of the target of evaluation. These are things such as the services that are running. Is there a website that is running there? Do we have an FTP server? Those kind of things. That is where we make use of Nmap. And remember, Nmap comes pre-built with Kali Linux. Okay, and also some of the other advanced penetration testing distributions. It comes pre-installed. Okay. And if we, in some cases, you can identify a web application running, which is just a website, an application that runs on a website. If you find a web application running, then it's worth taking a look by going in manually, going through the pages to see if you can find something interesting. Perhaps somewhere along the way you could find a login page that can be very interesting if you manage to break your way through it. These are some of the interesting things that you can do when you're manually going through that. And this whole act of manually going through these pages is called footprinting. Okay. There are other tools like Dirbuster and GoBuster that you can make use of, and this is to help you find those pages that may be hidden, that you may not be able to easily find just by the click of a button. They are more hidden from the index of the website. This is where you can make use of these tools like Dirbuster and GoBuster. There are others like DirSearch and so on and so forth. You can make use of those ones too. Okay. And this can help us find simple things like administrators, control panels, and so on and so forth. That's where it's going to basically come in handy. Okay. And then in the terms of web applications, these are some tools that we're going to be looking at in weeks to come when we're looking at web bug bounty hunting. That is Nikto and OWASP Zap. Okay, now these two are used to find web vulnerabilities. These are just vulnerabilities or mistakes in the security makeup of how the website was made. But then again, we're not going to be using these ones yet. That's for weeks to come. Okay, what really happens after that information gathering and reconnaissance? Well, unfortunately, there is no specific template that you stick to. That's due to the fact that everything that happens after this all depends upon what you found during that information gathering and reconnaissance. So your findings can be different, and therefore the steps after this can be a whole lot different. Okay. Alright. Just a little demo. Okay. And this is something that we did in the past lecture from the past week. So we made use of our virtual box. Okay. And we were breaking our way into a Linux, a Windows machine. So we had a Windows XP machine, and excuse me, and we made use of a special toolkit that comes with the advanced penetration testing distributions called the Metasploit framework. And Metasploit framework has certain tools that come with it. It's a Swiss Army knife, built to do a whole lot of things altogether. Okay. It has certain tools like MSF Venom, MSF Encode, MSF Console, and so on and so forth. But we're going to be using just a specific one, which is MSF Console. Okay. So here is my my Windows machine. So I'm just gonna boot up my Windows machine. Okay. And this time there is a password. Okay. So I'm just gonna write down my password. And there it goes. Okay. So there we go. There's my Windows machine. Okay. And now what I'm going to do is this. I am now, just minimize this. Okay. So now I'm going to hook up my terminal. So there. Okay. Just clear this out. So first things first is we wanna follow the kill chain and end up getting access to this Windows machine. And one thing we can notice for sure is we need an IP address. Otherwise we cannot communicate with that target machine. And to do this, we need a certain tool. If you remember last week, there was a tool called NetDiscover that we could make use of. So NetDiscover would send pings to every IP address possible within my subnet mask. Okay, and it will do this up until it gets an IP address that has a positive response. And the reason I'm doing this only is just to find an IP address for a machine that is alive. And voila, I have found it. PCS this is the machine. Okay, so this is the IP address of that Windows machine, 192.168.43.207. What I'm gonna do now is just gonna grab copy of that IP address. Okay, so all I did was just to get the IP address. Normally this part when you're performing a CTF, you don't even have to do this part. Okay. Then what happens after this is you can do a very simple nmap scan, but this time I'm going to do a very different nmap scan. I'm going to do an nmap scan with a vulnerability scan like this. So I'm telling nmap that I would like to specify a specific script, and the name of the script is called vuln, okay, which is a vulnerability scanning script. Okay, just gonna paste that there, and then we wait. Now what is happening now is nmap is going to perform a normal nmap scan like it always does, but now it's doing with extra parameters, whereby it's performing a vulnerability scan. And of course, when it comes to vulnerability scans, there's different kinds of vulnerability scanners that you can use. You can use different vulnerability scans like Greenbone, OpenVAS, or you could use other vulnerability scans like Nessus and so on and so forth, which is more premium level per se. But now nmap is more basic. It's not exactly updated all the time, but nmap is the case that we're going to use now. Okay, and there we go. I've got my response. So there is nmap, and I found some services that were running. On port 135, we found MSRPC that was running, and obviously, in most cases, you won't even know what MSRPC is, so you can do a simple Google search to help you get familiar to that service. Okay. And then added on to this, we've got this. Okay. On port 445, we've got Microsoft DS, which I think is Microsoft Domain Service or something like that. I'm not quite sure. Again, if you do a simple Google search, it will help you. Okay. And then you'll notice a response here. Okay. There's some vulnerabilities that were found based upon that service. Okay. And then when we base this on that port 135 MSRPC, there were vulnerabilities associated with that one too. However, after doing some research on some of these, one which will come out a little interesting is this MSO8067. Okay, if you do a simple research on MSO8067, you'll find that this is a critically rated vulnerability that's commonly found in Windows Vista and Windows XP machines. Okay, and it's vulnerable to a couple of exploits like Eternal Blue, or another exploit that you could find that's open to this is actually found inside the Metasploit framework. So what we're going to do now is we're going to open up the Metasploit framework, as I've mentioned, but specifically MSF console, not MSF Venom, MSF Encode and the others, just MSF console. Okay, so we're going to use MSF console, and inside this framework of ours, Metasploit comes with a lot of exploits for different kinds of vulnerabilities, but in this case I'm going to search specifically for a vulnerability that is associated with MSO8067. Okay, so we're going to let the Metasploit framework start. Okay, and again the Windows machine is simply open like that. There's nothing really much that we're doing here. Obviously, this could be someone just using their PC normally, maybe perhaps reading their emails or something like that. Perhaps this is something that they're doing. There's not much of a disturbance that's going on there. Okay, so here's Metasploit framework. Let me maximize this. Okay, so once it runs, you'll find it says MSF6. By the way, for those who would like to try out this exploit, you'll need a virtual box and you need to install Windows XP on that virtual machine. And I will post instructions on how to do that as well. Okay, so now that I'm in MSF, okay, in MSF6, there's different things you can do. If you want to play around, you can play around with the banner to get a different banner every time. Okay, but this is just to play around for noobs anyways. So what I'm going to do with MSF is I'm going to search for this string. Okay, and what I'm looking for are basically exploits that are related to MS08067. So I performed the search on MS08067, and if you look here, we found an exploit that's specific to Windows that runs on Samba. Okay, and Samba is just a service that's built into Windows machines that allows them to share files. Okay, then here we found one that deals with MSO8067 apparently, and this has to do with server relative stack corruption or whatever that is. But we found a viable exploit, and this is actually rated as great, which is wonderful. Okay, so I'm just gonna copy this. Okay, just gonna copy this. Gonna copy that. Okay, now back to the MSF6. I'm going to specify that I would like to use this and paste it right there. Okay, and you'll notice it says no payload configure. That's perfectly fine. So what I'm now gonna do is say show options. Okay, just so that I can see what is it that I am supposed to provide to this exploit such that it actually works. And if you look here, these are some of the things that I have to give, and some of these other things that you see here, they're actually more default. Exactly, I don't have to do this because they're actually set up for me. Things like the IP address and the local host port, that is already set up for me. All I have to set up is the remote host. Okay, so that's what I'm going to do. I'm going to say set remote host, and then I'm going to specify the IP address of the target. Okay, and I already got this IP address. I'm just gonna copy it from my old net discover. Okay, there we go. Okay, apologies. Then I'll paste this right there. Okay, and then if I say show options again, like so, you notice that it has clearly appended that, and this is all I need to do. And then now to run this exploit, I'm just gonna say exploit. Okay, and then you're gonna wait for a while and see if it actually opens a meterpreter. And a meterpreter is basically a command and control. It's a shell that allows me to pretty much control the target host. And if you look at the target host, there's really nothing that's happening. I had Outlook that was open with a wizard that's ready to run. Nothing that big. Okay. If I say help, you'll find some interesting things that I can do, like taking pictures with the webcam, for instance, taking screenshots, or doing different kinds, like getting the idle time and so on and so forth, or controlling the mouse and so on. Okay, we'll do something that's a little interesting, which is just take a screenshot. Okay, it doesn't seem like anything big, but just so you see the fundamentals of what you're able to do with the interpreter. So it says screenshot has been saved to home, Nash, and then there's a file like that. So if I take my file browser, if I go to home, okay, I'm already Nash, so I'm perfectly fine. There should be a screenshot here. There we go. And this is what the Metasploit framework just created. And if you look at it, this is exactly what's on the screen. And there is no sign that there is anything that happened on the other end. Okay. And that is the weakness to that system. It's because it was not upgraded. Okay. Then, of course, if you were to follow the cyberkill chain, you would get to a point where you need to maintain access. When it comes to maintaining access, you may need to find the passwords, because you saw we never really found any passwords along the way. So what would be the right thing to do in this context? So what I would do is perform a hash dump. Okay, in the hash dump, hence I did this, is to dump contents of what is known as the SAM database. And the SAM database is a database that comes with Windows, and this is a database where all the hashes are kept. And the hash is basically a key that represents the password such that it doesn't look directly like the password. If you look at this, the Nash user account, which is the one that's actually being used here, you'll find that's actually Nash. That's the user account in that case. That Nash user account, this is really not the password, really. That's like not the password exactly. But this represents the password. It's an encryption. You can change a password into this, but you cannot go in reverse. You'd have to crack it. So what people would normally do is you would save this in a text file so that you can crack it later on. Okay. So what I would do is I'd say hash dump, and then I'll use the greater than symbol so I can save this in another file. Let me call this samdump.txt. Okay. This, you recall, is something that we did. You learned in week 1, isn't it? How to write down a command and output everything into a text file. So I've saved everything into samdump.txt. If you look here, if you look at the home, there should be a file created for that. It doesn't seem like there is. Okay, that's probably because I'm in MSF, but that's perfectly fine. That's something you could do. Okay. Now I'm just gonna exit out of this. Now we don't really know what on earth we can do with this, but as we proceed with the next theory, you'll understand where these hashes would actually apply. Okay, so let's talk about password attacks. So password attacks, the idealism of password attacks is all about an offensive action whereby we're trying to gain a password or recover a lost password, or a lost key phrase in this case, of a certain target. Okay, and this requires a deep understanding of the target of evaluation. You may notice that the hashes that I found are Windows hashes in this context. They are just Windows password hashes. However, the way in which you can recover the password to a Windows machine is very different to the way in which you would recover the password from, say, maybe an Instagram account or something like that. It's different. So you have to understand your targets of evaluation. Okay. Anywho, anyhow, let's just talk a little bit about authentication itself. The idea of authentication is the procedure where we're letting someone into a system based upon them proving something. Okay, you prove something, as soon as you prove it, we'll let you in. Okay, just like your computer, as soon as it logs on, you will see an authentication page where you're supposed to prove something. And what are you proving in that case? Well, what you're proving is the fact that you know something, like a password of some sort. If you prove that you know the password, then you will be allowed in. Okay, so here are the kinds of things that you may require in terms of authentication. You will require to show something that you know, which is like passwords, PIN numbers, and so on, or what you have, which is something like a tag or a employee badge of some sort. Okay, something that you have, or it is something about you. This is where we're now talking about biometrics features, things like your fingerprints, your paw print, or your voice, or your iris, and so on and so forth. Okay, this is something about you. Okay, so in terms of authentication, each of them have a weakness of their own. Okay, just like pins and passwords can be cracked, biometrics can be cloned, like fingers can be cloned themselves, or you can have false positives. This happens whereby your biometrics allows the wrong person in just because it looks similar of some sort. Okay, and then when it comes to what you have, those can just be given off to someone or stolen. Okay, each of them have weaknesses of their own. But now we are in this case more focused on the what you know part of it. Okay, the passwords and pins. First type of password attack to note is shoulder snuffing. And the idea of shoulder snuffing, for some odd reason, this apparently is a password attack, and it is very common as well. And it's more aligned to a social engineering vector. This is just to say that it's more attacked to the person rather than technical. Okay. Now what happens here is a person just looks as you type the password and then remembers it like so. And then before you know it, once they gain access to the phone, they can log in because they know the password. And many people can just say type faster. I mean, that's the best idea. Rather, just make use of biometric. It's a way better approach. Just use a fingerprint. It's not like they can copy your fingerprint by looking at it. That's a whole different scenario. Okay, so you can either type faster if you're able to, or just make use of biometric security, or have a longer one that is just tiring to remember. Okay, then next we have dictionary attacks. Now, dictionary attacks is where we make use of a list. So you have a text file that has a list of commonly used passwords, or some of these passwords you actually add or append on your own into this word list. And basically we're going to try all these word lists one by one up until we find the correct password, like so. Okay, and normally this just depends on the password itself. Okay, some people can use English passwords, which makes them very difficult. Okay? If it's an English password, it becomes an easy to crack. If it's a combined phrase, then it makes it more difficult. Okay, so to avoid that dictionary attack scenario, you would want to combine your passwords. Have like part of a word, then a number of some sort, a part of a word, a number, some symbols. Combine them and mix them up as much as you can. And of course, you have to then remember the password itself. Otherwise, you cannot be locked out of your own system. Anyhow, then we have what is known as a brute force attack. A brute force attack, it takes the longest depending on the password itself, depending on how long the password is and the kind of characters that make up that password itself. Okay. And what happens during this brute force attack, what happens is that we make use of what is known as a brute force algorithm. Okay, and it tries all permutations of a password up until it finds it. For example, let's just suppose that there was a password that is 3 characters. If I'm to try AAA, AAB, and AAC, and I keep going all the way until ZZZ, and then somewhere along the way I will find the 3-digit password, provided of course that it's only lowercase alphabets. If I'm using that brute force attack, then it would work like so. Okay, and you would have a much better success rate if you're performing a brute force attack if provided you know the length of the password and say maybe how many or what kind of characters rather. Say, do I have capital letters only or lowercase letters only, or do I have a combination of something and something? Once you know that, then you know what to include in the scope of your brute force attack. Okay. Then there's thus known as a rainbow crack. And rainbow crack makes use of rainbow tables. And what rainbow tables are are essentially these documents that are full of hashes, okay, which are cryptoanalytic hashes. And these are just hashes, just like the one that you saw we got from the SAM hash dump. It's full of these partially so, and each of them are mapping to different characters. And it's making use of this complex algorithm to mix match these hashes to characters up until it gets that password that responds to it. Okay. And this doesn't exactly take much on processing power, but memory, because these rainbow tables are huge in terms of space. We're talking gigabytes to terabytes of space. Okay, demo time. So now that we have found these hashes, okay, we're going to make use of a certain tool called John. Okay, John the Reaper. And John the Reaper comes pretty much pre-installed with your advanced penetration testing distributions like your Kali Linux. Comes pre-installed. So what you need to do with John is you need to copy that hash dump that you have. Okay, we're gonna copy that hash dump, and then we're going to just use a little text editor, okay, notepad or whatever it is that you can use. Okay, we're just gonna make use of it. Okay, and you're just gonna paste it there and then save it there like so. Okay, you can save it. I don't know where I can save it. Let me save it here per se. Okay, let me save it as hashes.txt. Just gonna save it right there. I'm gonna replace it. Okay, that's one tool that we can use. We can use John the Reaper, or we could use this special tool called Cain and Abel. That's another special tool that we could use to perform that. Although Cain and Abel is rather old, it's more aligned to those that are running Windows machines. Let me exit out of this. In fact, I have Cain and Abel here. I might want to. Okay, I have Cain and Abel installed on my Linux machine. Although, as I've mentioned, it's a Windows software, so it's not exactly the kind of software that you can run on a Linux machine. But mine is able to run this only because I made some changes to it. So let me just take this to Windows so that I can try it out. Oh, I think I might have to take it to maybe my documents, for instance. Okay, let me just see if I can take it there. Hope it doesn't scream at me. Okay, I think we'll do that one the Linux way anyways. That's perfectly fine. Okay. We have those hashes. Let's try it by route of using John the Reaper. So here I've got hashes.txt. Okay. So there's hashes.txt. I've pasted those hash dumps that I got from Sam's database. Okay, those are password hashes, by the way. It's not exactly the password, but we're going to make use of John the Reaper to find that password specifically. And using John is very easy. Let me clear this out. Using John is very easy. You can use John from the terminal, or you can use the more graphical version of John, which is called Johnny, which is a GUI version with buttons and everything. It's much easier to use than John itself, but let me show you both ways. So if you're using John, you can say John, and then by default, if you don't want to give any extra information, you can say John and then just paste in the hash file there. Okay, oops, there, and then just hit enter, and then you wait. Okay, so what it's doing right now is it's attempting to crack the password. Okay, and it found a D. I don't really know what the D is all about, but anyways, the password cracking proceeds like so. Okay, that's John anyways. If you want to specify, of course, remember we mentioned that there's different kinds of password attacks. You can try to perform a dictionary attack by specifying word list, and then you can say equals, and then you can paste your word list in there. Remember, the word list is just the file that has the words that you would like to try for your dictionary attack. Okay, and then you try those like so. Okay, and of course this one doesn't really work for some odd reason. Okay, but anyhow, you get the concept. Okay, so that is that one. Another tool of trade for you to use is Johnny, which is the GUI version of John the Reaper. And to execute that, you're just gonna say Johnny if you're doing this from Kali Linux. If you're doing this from parrot, you might have to install it by saying sudo apt install Johnny. You'd have to do that. But in my case, my installation for Johnny is a little bit different because I got it from a Git repository. Okay, oops. Let me clear this out. Okay, so there's my Johnny. Okay, so for my case, if I want to run Johnny, I have to do it like this. But for your case, it's a little bit different. And if, as you can see, Johnny is more graphical. It's more user-friendly than the old John the Reaper that you just saw. So I'm going to go ahead and import a password file. Okay, so I'm just going to navigate that. This is at my desktop, and this is hashes.txt. Okay. Oh, and actually by default, it actually got the first part of the password. Okay, there it is. It said it's password. Okay, that's because I've done this crack ahead of time, but by default, you're not going to really get that password. So you might have to go to options and specify things like a word list file if you're going to do a dictionary attack. You're going to do a single crack, which is kind of the equivalent of a combo-based attack of combining different attack vectors together. Or you can use incremental mode, which is a brute force attack. I don't know why they gave them those names for some odd reason. But anyway, you can try out a word list attack. And still, in my case, I got the password anyways. So the password in this case, it says the password is password, which is fairly fine. So John can take care of business. Okay. If you were using Cain, on the other hand, Cain, actually the full name of this tool is actually Cain and Abel. It was made a long time ago. So it's a little bit old and it's more aligned for use on Windows machines, specifically Windows XP all the way through to Windows 10 can actually use this tool. It's a Swiss Army knife for pretty much all your password attacks types. Okay, not to browse too much into it, I'm just gonna go to the Cracker tab. I've already imported these, by the way, but let me just delete them so you see how the importing is done. You can just click on this, and then here I can say import hashes from a text file, and then I can browse through. So these are in my desktop, and this is hashes.txt. Okay, and I can click on next, and you'll notice that it will import them like so. Okay, then once you're done with that, of course, let me modify this this text file. This is .txt, because Cain and Abel only uses text files for performing those cracks. Okay, so here's Nash. Per se, I would like to work with this one. So I can say here, I would like to crack the LM hashes, which is these hashes. I can crack those hashes or those hashes, any of those that you would like. It will crack either way. Okay. Once I'm here, I can specify the options that I would like, but in my case, out of the word list, I would like to just try out those words as they are. Okay. Let me just remove this one from the list and let me just work on this one that's in the desktop. Okay. I'm gonna reset the position so it starts everything from the beginning. And then if you start that crack, it will try all the way through. And you'll notice something. It says the plain text of this is password. Really, that's not the password. We saw that John said it's password and not password. So you'd wonder where on earth is the D. That's perfectly fine. You can try the other one. Okay, you can see it actually has question marks there. Kinda incomplete anyways. But by looking at this, you can pretty much guess that the password is password. Okay, we can try the same thing against the NTML hashes as well. That's perfectly fine. So I'm gonna go there and reset its initial file positions as well. Okay, let me just reset these so it just tries the passwords as they are. I'm gonna start that, and this one actually gives us the full password. The password is password, which is wonderful. Now we have found that password by using that one. So this feels more trusted. Only now this one is actually coming out into the blue. But anyways, now we know the password, and now we know how to gain that privileged access to this Windows machine. So per se, if I was to log off out of this machine, like so, I can never get tired of that sound. If I now give in the password, you will notice that is the actual password itself. So that is the idea and the concept of using hash dump. Okay, so keep that on. Okay, back to theory. Okay, so that is how we perform those password hashes using Cain and Abel or John the Reaper. Okay, so now back to the theory. Okay, another way in this case of actually gaining those passwords is by making use of social engineering vectors. Social engineering is all about exploiting the human weakness, which could be just lack of knowledge, or it could be just total ignorance on its own. Okay, this is where we make use of engineering techniques like phishing or credential harvesting or vishing. Of course, by this point in time, some of us are quite familiar with what phishing is. For those who have no idea what phishing is all about making a legitimate website and making a copy of it so that you can, well, pretty much log into the fake one and get your password. Okay. Then there's credential harvesting. Credential harvesting is all about being in a network and just sniffing for passwords the whole time. Then we have vishing, and vishing is all about giving someone a call. So this is more aligned to the voice type. So you can call someone and then pretty much impersonate and trick them into giving you information. For instance, you can lie to them and say you work at a certain bank, for example. Can you please confirm your ID number or your social security number? And they would give it to you because you pretty much impersonated someone who is of trustworthy. Okay, and then there's smishing, which is the SMS kind. Okay, then there's dumpster diving, where you literally dive into the trash and get some information from there, which could be some passwords of some sort. Okay, and then there's lock picking. For some odd reason, that's also a social engineering vector, because picking locks will pretty much bypass authentication measures that we were talking about not so long ago. Okay, and demo time. So when we looking at social engineering vectors, there's a whole lot of tools you can use for social engineering. One that sort of screams out in Kali Linux, you'll find one called the Social Engineering Toolkit, or SE Toolkit in short. Now, in my case, I don't actually have it pre-installed. I have rather the repository instead, and Social Engineering Toolkit. Okay, but if you're doing this from Kali Linux, if you just run sudo social, or not social, SE Toolkit on your terminal and you hit enter, you're pretty much gonna get the SE Toolkit. But in my case, I have to do things a little bit different, so just bear with me. Okay, so I'm just gonna go into that, and then I am going to run it. So I'm just gonna do sudo, and then this is against SE Toolkit. Okay, just gonna type in my root password like so. Okay, and there we go. You're going to have the SE Toolkit run like so. And the Social Engineering Toolkit has a whole different attack vectors that you can try out. Okay, and we want to choose specifically the number one, which is social engineering attacks. Okay, and you have different kinds of social engineering vectors. If you look at this, you've got spear phishing. Let's take a look at what's in spear phishing. You have things like sending out emails to different peoples, or creating a file that has a payload. So that's the kind. If you remember last week, we looked at poison. We looked at an instance of poison ivy, where we made a little file that we sent to Windows, and we opened it, and it pretty much gave us access to it. In this case, you can create a file that is not exactly as suspicious, like a PDF file. If someone opens that PDF file, then you pretty much have access to it. That's the idea of that file format. Okay. Then we have website aligned type of vectors. This has to do with cloning websites and hijacking tabs and so on and so forth. These will look more when we're looking at web bug bounty hunting. So not exactly more aligned from that, but there's different other kinds. You can do QR codes. I can create a little poster per se, and that poster can have a link that opens to a vulnerable website. And on that poster, I can just say win free money by scanning this below, and someone would scan that and pretty much go to that page, and before you know it, you own them. Okay, but I'm not going to look too much into the SE toolkit. Okay, I'm going to look at those that you do not have. Okay, so in my toolkit, I've got a whole lot of different kinds of tools that I have here in store. Okay, and the one that I would like to specifically show you for this demo is number one, which is this one, HiddenEye. And HiddenEye is a phishing toolkit. Okay, so I'm not gonna show you how to install HiddenEye as of yet. You can do a simple Google search. I'm sure it can help you out. Okay, so if I would like to run HiddenEye, I'm just gonna run HiddenEye. So I'm just gonna say Python 3 HiddenEye.py. Okay, so when you're running HiddenEye, it runs quite the same way as the SE toolkit. All you have to do is give the numbers, and you keep going with the prompts up until you're done. It's pretty straightforward and pretty basic to say. Okay, so let HiddenEye do that. I think it's going to try and look for updates. Oh, there we go. So there's HiddenEye. So HiddenEye is pretty simple. We've got different pages, different phishing pages to try out. I wonder why this one is here, but anyways. So let me just try one of these. Let's say Google, for instance. I'm just gonna select two for Google. Okay, and I would like the standard page type of phishing. Okay, and I don't want to install keyloggers or anything like so, so I'm just gonna hit enter. Okay, and then I can put a redirect URL. This is to say, after the phishing has happened, which page would you like the target to be redirected to? So let's just say maybe I would like them to be redirected to google.com. That's perfectly fine. Okay, and then I'm just gonna use 8080 as the current port for this web server. Okay, so it's going to create a website that looks exactly like Google's login page. Okay, and then I'm going to say localhost for that. And if you look at it, this is what I have. Okay, this is the link that I got. So if you try and open this, let me open a new Firefox tab. I'm just gonna open a private window here. I'm just gonna paste this there. Okay, and if you see, this says Google account sign in, which is very interesting. But for obvious reasons, obviously, if I was to give you this link, you would not get this website. That's because 127.0.0.1 is a loopback address. So it's more a more private IP link type of thing. So I have to open this website to the public. Okay, so I need a link that's more exposed to everyone on the internet. Okay, but luckily there's this wonderful service called Servio. Okay, and if you go on Google and you just search Servio, there's something wonderful. There's a service called Servio which allows you to perform tunneling. And the idea of tunneling is opening a port on your computer to the internet, so that you'll get a specific link that is open and can be used by pretty much anyone on the internet. Okay, so once you give the person this link and they open it, then they're able to see that that HiddenEye webpage. Okay, so apparently I have to do this for some odd reason. That doesn't look like a bus. Okay, anyways, so there's Servio. Okay, Servio.net. That's the website I'm going to go to, and all I want to do is expose my local server to the internet using SSH. And SSH is something that comes pre-built with Linux, so it's not something I have to install anyways. So I'm going to use Servio to get a link that is more open to the internet, so I can pretty much share and do something like a phishing campaign of some sort, and pretty much share it with the internet and see who's dumb enough to open that link, even though the link that you're going to get is not exactly an easy type of link that people would fall for, but you'd be surprised. So here, I'm just going to run this command. Okay, so I'm going to copy that. I'm not going to run this inside HiddenEye for obvious reasons, because if this closes, then the whole web server closes. I don't really want that. So I want this in a new terminal, which you can use Control-Shift-T to open a new tab, by the way. Okay, so if you do this, you'll notice this is actually not going to work, because this is actually doing this to port 3000. Remember, ours is doing this on port 8080. Okay, so I'm just going to specify in place of that 3000 that I would like 8080. Okay, then I'm going to hit enter. Then wonderful. There we go. I got a link to attempt to perform that phishing. So this is the type of link that you're able to share with pretty much anyone on the internet. And of course, Servio is not the only way. There's different kinds of services you could use, like NGRock and all the others, but I'm not going to use those. I'm just going to use Servio. And of course, if someone opens this link, they would more inclined to get a page like that one. Okay, and you would enter your details onto that page, and it would harvest out your credentials like so. Okay, so it seems the internet is a little bit slow for me, but now for the sake of testing, I'm just gonna do this on this one. But the same effects would happen. It's just that this one is more open to people on the internet, and this one is more local for the sake of testing. Okay. Oh, yeah, we actually got it now. Okay. So now what I'm going to do is I'm just going to type in some test credentials. Not really true credentials to say they are mine, just test usernames and passwords and see if we can be able to capture them with the HiddenEye. So I'm just gonna type in this. This is not really my email address, but for the sake of testing, we'll type in Tinashe Judas there. And if you see, the behavior of this page is pretty neat. It looks just like the real deal. Okay, just like the real deal. Even the logos there looks like the real deal. Okay, and then you type in your password there, because I mean you think it's a real web page anyways. So we'll say let's just type in some randomized password. Okay, then I would hit enter. And then if this is successful, if you recall when we configured HiddenEye, we said that it should redirect you to google.com. So if you redirect it to google.com, which seems like what it's doing, it seems fair enough. So if we go here, here's HiddenEye. It said credentials found. It found some credentials. It says the email address, Tinashe Judas, and the password, which was this that I entered, which is not really my password, but you get the idea of phishing after all. Okay. Control C to stop that. And then let me exit out of that. We are done. Okay. That is the whole concept and idea of phishing. And there's different kinds of services out there that work out quite well. Okay. Let me show you another one. Okay. But this one is not more of phishing. This is called Seeker. Okay. You're not gonna find it in Kali Linux again, because these ones are pretty dangerous. Okay. So I'm going to execute with Python 3. I'm just gonna execute that script called Seeker. Okay, then let me say I want this web page called near you. Okay. So there my my PHP server, it's running perfectly fine. Okay, and it's running on port 8080, so this still works, by the way, because remember this points to port 8080. It's just that I don't have that Google page that I had before running there. Instead, I have a different thing there. So I'm just gonna paste that link there. You can regenerate a new link, of course, using that Servio if you'd like. That's perfectly okay. So now we just rendered a new website called Near You. They said find people near you, meet new people, make new friends. Ah, that's pretty cool. Continue. Okay, well, obviously, if I'm gonna find people near me, I should access my location, right? It's gonna allow that. Okay, but that was where the mistake was. If you notice, for this guy, okay, this is still running for some odd reason. I've got quite a slow internet. I can try this once more. It's gonna take quite a while. Okay. So what happened now is I allowed my location to be accessed. Okay. And of course, this is not the only thing you could do. You saw there were different other pages that we saw, like WhatsApp and Telegram and all those kinds. Anyways, it says, thank you for taking interest in near you. This product is upcoming soon. So normally you just be like, ah, damn it, that's useless. Okay, that's perfectly fine. You'd close out of that website, which is fine. But anywho, anyhow, if you look here on my dear friend Seeker, it found some pretty interesting information. This is a Linux machine and some information about that machine and so on and so forth. It even gave me a Google Maps link, of which this Google Maps link is the one that would lead to your location. Okay, in my case, in the middle of some river somewhere. In case you're thinking this is my location, this is really not my location, by the way. But you get the concept and idea. So this is something that we see there. Okay. But of course, that's not my location. That's because I have masked my location. Okay. But of course, normal cell phones or normal PCs, they would give you the direct location anyways. That's an instance of that phishing in action. Okay. So that is pretty much it with those demos and social engineering vectors. Now, the video that proceeds after this will be trying out a CTF. Okay, and the name of this CTF, so this is now where we are more now looking into HackTheBox. So if you recall, we said we're going to be trying out some CTFs, capture the flags, which is a whole environment where you're given some vulnerable machines for you to pretty much hack into and try your best. So at this point you need to ensure, of course, that you have a account with HackTheBox. Once you have an account with HackTheBox, I will see you guys with the next video, and in that next video we'll be trying out the CTF of trying to obtain one of the CTFs or one of the machines that are provided in HackTheBox. We'll be trying those ones out and trying to hack our way through a Linux machine in this case. So I will see you guys in the next video when we try out the CTF. See you guys in the next one.